which is the Kiosk engineering demo session conducted by Kiosk Native. And the session will be led by Mr. Ajesh Baby, Director of Engineering at Kiosk Native, and Mr. Nilanjan Manna, Software Engineer at Kiosk Native. Now, I'm handing over the mic to Sibin John to introduce our today's topic and speakers. Sibin, please.
Thank you, Jijo. So welcome everyone and good evening to all. Welcome to the 27th room of DevOps Malayalam community. And last week we had a small talk regarding the chaos engineering practices and the Litmus chaos tool by Ajesh in our mother tongue Malayalam. But since we are going to the demo and it's a bit more technical, and to speak and to introduce the practices to the large fraternity, we chosen the languages English. That's why today we are conducting in English language. So please be cooperative, everyone. And today we have Ajesh Baby, as Jijo mentioned, Director of Chaos Native, and the product owner of Litmus Chaos. The version 2.2 launched last week. So it's a very good moment for them. And Nilanjan Manna, Senior Software Engineer and a DevOps Engineer from Kiosk Native. So guys, welcome on board, and this screen is for you.
Thank you all. Hope I'm audible.
Yes.
Yeah, sure. Thank you for providing this opportunity, and probably we'll cover chaos engineering at a brief, and we'll go with the demo session. All yours, Niranjan, probably you can start.
All right. Thank you so much, Ajesh. Thank you, everyone. So hello and welcome to this session. I'm Nilanjan, a chaos engineer working with Chaos Native and a contributor to the fellow Litmus project. So let me just share my screen. I hope my screen is visible.
Yes.
All right. Thank you so much. So hello, everyone. Good evening. Welcome to this session on Introduction to Chaos Engineering. Myself, Nilanjan. As I introduce myself, I'm a chaos engineer with Chaos Native, and I'm also a fellow contributor to the Litmus project. Along with me is Ajesh Baby, Director of Engineering at Chaos Native. So today, we are going to give you an introduction on chaos engineering and how to use Litmus Chaos to perform chaos engineering. We have a lot to cover, so let's hop right into it. So first of all, let's discuss the agenda that we are going to cover in a minute now. So first of all, like, what is chaos engineering? Why do we need chaos engineering? How do we perform chaos engineering? After that, I'll give you a brief overview of what is Litmus Chaos. And finally, we'll come to our demonstration of Litmus Chaos. So without any further ado, let's begin. Before we actually start with the presentation, I would like to give you a scenario. Let's say you have deployed your e-commerce application using Kubernetes, and you're very satisfied with how flexible and stable your application deployment has come to be. During the testing of the application, it had checked all the boxes, and you're very confident that your application deployment is all set for to face peak hours of the sale next week, which will have customers, let's say, all over the country trying to buy your products using your application. But you know what happens? Alas, right on the peak hour of the sale, you face of service outage. What actually went wrong? But you don't have any idea, since on a superficial level in your application, nothing seems out of the order. Everything is correct. Your application deployment seems to be correct, but it's not working. So now the fact is, could this situation have been avoided? The answer is yes, and that is using chaos engineering. So chaos engineering is the discipline of experimenting on a software in production in order to build confidence in the system's capability to withstand turbulent and unexpected conditions. So chaos engineering mostly emphasizes on experiments, which are otherwise called as hypotheses, and then compares the results of those experiments to a defined steady state. It is also regarded as the science of breaking things on purpose or productively breaking our systems to identify the unforeseen weaknesses of the system before they wreak havoc in production. More than just fault injection, chaos engineering is an attempt at understanding the factors that lead to the instability of a system and gaining insights from the behavior of the system as a whole when it is subjugated to an adverse situation, with the ultimate goal of making our systems more resilient in the production environment. So, to give a great analogy that even I had learned a few days ago, it is like a vaccine. Where in vaccine, what we do is we inject chaos, we inject some mal something, some kind of we can say harmful substance that can potentially harm us, but with the objective of providing us immunity. So we can say that chaos engineering is almost same. We are over here injecting chaos with the larger intention of building resiliency in our systems. So why chaos engineering? I mean, how do we landed in this sphere? So when we discuss our application resilience on Kubernetes, it is not only our own application that is responsible for this. As we can understand, our application sits on top of a host of other services and infrastructures. So there can be attached databases such as MongoDB, let's say Kafka Broker Pods, or we also have a PostgreSQL databases that are responsible for the stability of our application. Then we have our cloud native services such as OpenEBS or Prometheus, CodeDNS, you name it, that sits on top of our Kubernetes services, our native Kubernetes services that support our application deployment. And finally, we are also dependent on our platform services, that is the infrastructure on which we are deploying. It can be anything starting from your bare metal to your on-premises cloud or your public cloud services, whatever the case may be. So that's the whole complexity that is being associated with your application as soon as you're moving to a cloud native environment. And one can clearly understand that the resilience dependency goes downward. And in order for your application to be completely resilient against any fault, it needs to be resilient from top to the bottom. It has been identified that more than 90% of resilience of your application depends on other cloud natives components and the infrastructure. So now the biggest question is, as soon as you verify that your application is working fine and is behaving as expected, how would you ensure that your application, that the services that your application is dependent on are also resilient against any type of failure? The answer is chaos engineering. So to answer our question in a broader sense, that why do we need chaos engineering? As I told just now, excuse me. So as I told just now, it helps us to recognize the dangers and their consequences. By allowing you to create an experiment and to quantify how it affects your business, chaos engineering allows you to understand the influence of turbulent conditions on important applications. Therefore, the companies can now make informed judgments and react proactively to avoid any kind of losses when they understand what at risk. Next is quick reaction time when an unexpected yet known failure occurs. So this is one of the biggest advantages of performing chaos engineering, because distributed systems are so complicated that there are several ways for things to go wrong. The notion of disaster recovery and business continuity is critical for firms in high regulated contexts, such as the financial industry, because even a single instant of an outage can be very much costly. These industries may rehearse, prepare, and put a million different mechanisms in place for real life situations by conducting chaos experiments. When an incident occurs, then chaos engineering allows teams to have the correct level of awareness and plan and visibility already ready so that they can respond to that event very quickly. Next is improved application security and observability for enhancing reliability. So chaos chaos experiments helps you to figure out where your system's monitoring and observability capabilities are lacking, as well as your team's ability to respond to those crises. Chaos engineering will help you identify areas for improvement and motivate you to make your systems more visible, resulting in better telemetry data, which again lead to a better decision-making capability. And last but not the least, it will assess the failover plan and the cost involved in a safe environment. So now the question is that the failure is about to occur and we know that okay, something might happen, and therefore we'll have a plan for it. We may have a backup database, we may have a backup server, it can be anything, you name it. But now the question is that, is our plan the most efficient one? More, and there can be many things from which we can assess the feasibility of this plan. It can be either the cost of that backup plan, or it can be the technical feasibility of that backup plan, that is how good it is working. We don't know unless we actually try it. So therefore, chaos engineering provides us a safe environment where we can perform these failures and know that which failure plan or which chaos disaster recovery plan works best for us, and therefore it allows us to make a very informed decision. So that's all the reasons that we have for why do we need chaos engineering. Moving on, how do we perform chaos engineering? So chaos engineering can be abstracted into 4 simple steps. The first step is to identify a steady state. A steady state is a state in which we desire our systems to be. Like, for example, we can say that we have our e-commerce application that we were discussing before. It is composed of various microservices, which can be deployed in their, let's say, own pods, own deployments, you name it. And we can therefore validate a set of, let's say, count of pods, or let's say our count of deployments that we have always present in order to sustain a disaster. So that's our steady state. And this is, by the way, not only limited to Kubernetes or pods. The steady state condition can be any condition in which we desire our systems to be. Once we have identified our desired steady state, we move on to describe a hypothesis. And hypothesis is something we think that, where we say that okay, this component can lead to a disaster. We hypothesize that something in our system can fail, or a set of conditions when occurring together can make our system go into a inconsistent state. So that process of identifying what are the conditions that can lead to a disaster is what we regard as hypothesis. Once we have our hypothesis ready, we can design our experiment. A chaos experiment is something that actually injects our chaos into our systems. So now this chaos injection can be at many levels. As we were understanding from our pyramid diagram of a few slides ago, that our application is dependent upon a host of other cloud native services. So potentially a chaos experiment can target any of those platforms, even more than one platform at the same time, to inject some chaos and to analyze its effects at the same time. We need to understand at this stage is that chaos engineering is not only about injecting chaos into our systems and breaking them down. It is an attempt at understanding our systems in a new light. That is to identify what is the behavior of our systems when it is subjugated to a turbulent condition, and find out insights from it so that we can make changes to them. So that is what is leading us to our next step, that is adapt. Once we are done with our experiment, that is we are injecting chaos into our application deployment or our systems, we can pick out the insights from that experiment. This can be any insight. For example, if we have an e-commerce application, if we perform a pod, if we are, let's say, deleting our deployment pods, and we are saying that okay, this deployment should sustain this pod deletion. So we can say that, okay, fine, if it sustains this experiment, then we can say that, okay, it is resilient. And if it is unable to sustain this experiment, then we can say, okay, it is not resilient. So what will we do then? Of course, we need to adapt. We need to make some changes in our system so that we can make it more resilient. So of course, here we identify all those factors that can lead to our instability and work on them. As soon as we work on them, we then work upon finding our steady state again. That is, we recognize a new steady state, and therefore this cycle goes on until we find a perfectly resilient system for us. Moving on, so I'd like to introduce you to the Litmus, but before that, if there are any questions, I'd like to take some. So if there are any questions, please. All right, I guess we don't have any questions, so I'll move on to Litmus. So the Litmus is a cloud-native chaos engineering platform. It is a tool set to do cloud-native chaos engineering that helps both developers and site reliability engineers in automating the chaos experiments at different stages. That is within the DevOps pipeline, like during the deployment or during the CI/CD or even in production. So normally everyone says that don't test in production, don't make changes in production, but chaos engineering is all about testing in production and breaking things productively. And therefore Litmus achieves this in introducing chaos in all the levels of in all the levels of the DevOps pipeline, including deployment, CI/CD, and production. It adopts a Kubernetes native approach to define chaos intent in a declarative manner via the custom resources to target Kubernetes containers, public cloud, bare metal application, then application resources, you name it. So we are 100% open source project that has more than 50 plus chaos experiments. The Litmus project has been installed more than 196,000 times, and it has 471,000 plus experiment runs. There is something known as Litmus Sdk, which helps us to define our chaos experiments, and it is available in Golang, Python, as well as Ansible to assist all the developers and SREs to create their own chaos experiments. And of course, it has been adopted by many enterprises such as VMware, Red Hat, Intuit, Wipro, Lenskart, and many more. So that's a brief introduction to Litmus, but of course, we'll see it in a much more greater depth in a short while. So right now we can move on to understand that how Litmus is going to work, or like how we can make it to work. So in order to install Litmus, it just works with Kubernetes 1.17 or later, and one should have a persistent volume of 20 GBs or more. It can be installed using Helm or kubectl, and most prominently, it can be installed in namespace scoped installation or a cluster scoped installation. Now, the namespace scoped installation basically helps us to create a multi-tenant cluster where if there are more than one tenant using a cluster, then we can reduce the impact of our chaos experiments, which we define as blast radius of an experiment, to a particular namespace only. So therefore, we can safely perform our chaos experiments without causing any harm to any of our other deployments or any of our other application in other namespaces. And as you might have guessed, cluster scoped installation is just the opposite. It allows you to perform chaos experiments with a much larger blast radius upon all the different namespaces inside your Litmus. So of course, installing Litmus is very simple. There are 3 simple steps. So over here, I've shown the steps for Helm. So you just need to copy the Helm repository, then create the namespace, namespace for the Litmus where Litmus components will get installed, and finally simply install the Litmus. So Litmus has something known as a chaos center, which we are going to explore in just a while.
Yeah.
So
Sorry.
yeah, sure.
Just take off others. Like, so if you are installing on your local machines, it's like Kubernetes cluster does not mean that you need to have an entire Kubernetes to try out. Even a mini cube on your local laptop, you can install and try it out. So the recommendation 20 GB is for the develop or like deployment kind of things. It can go as less as 500 MB or like 1 GB is good enough on your local laptop to try out everything.
Right. So these are some quick handy references. So it's time to perform our chaos experiments. So it's time for the demo. So before we move on to the demo, let me just stop sharing and share my whole screen. So that will be switching quite a few tabs. All right. So I hope my screen is visible, and this is what a Kiosk Center looks like. I've already made an installation of Kiosk Center or Litmus Kiosk into a EKS cluster. So using only the 3 steps that I've shown you just a few times before. So as soon as you install Litmus Kiosk, I can show you the resources that appear once you are done with the installation. So I can say kubectl all that's an Litmus. Okay, so all right, seems to be some issue. All right, I guess I'm here having some issue with my terminal, but no worries. I guess we can proceed on with our Kiosk Center. Not sure what the issue is.
I
So
think,
as yeah.
Niranjan, you may have to set the kube config thing. It is out right now, or like AWS session has been.
Right. All right. Just give me a few seconds. Just give me a few seconds. All right. I guess we are having some technical issues. Not sure what is happening really. But I guess we'll be fine through the demonstration. I can show you through the web UI. That is what Litmus Kiosk really does. So apologies for the trouble. All right. So let me just give a description of what happens when you install Litmus Kiosk. As soon as you install Litmus Kiosk, all the services get installed in your Litmus namespace, and you'll be able to see there are a lot many services, such as the first of all is this front-end application, which gets installed as part of your Litmus installation. Then there is a backend component. We can refer to the documentation today, so that I can give you a brief overview of what Litmus does. So as we can see over here, Litmus is actually composing of these 2 components. First of all is Kiosk control plane, and second is Kiosk execution plane. Kiosk control plane is what you are seeing right now. That is, my Kiosk Center is part of our Kiosk control plane, and it resides inside along with different other services such as Auth server, our MongoDB, as well as the GraphQL server. So the GraphQL server is responsible for mitigating all the different requests that are posted from Kiosk Center, and the Auth server is basically responsible for authenticating any user that is trying to log into our Kiosk Center. The Kiosk Center is not only this web user interface that we are seeing over here. It is actually consisting of our command line interface as well as our Litmus API and the web UI. So these 3 things form of our Kiosk Center. The GraphQL server is then using the subscriber, which is present inside our Kiosk execution plane, in order to communicate the different commands that we are trying to perform as part of our Kiosk engineering. So for example, like if we are trying to execute any Kiosk workflow, we'll just understand in a short while that what is a Kiosk workflow. Will that request goes to our subscriber that is present inside our Litmus agent infra. The Kiosk execution plane is composing of 3 subsections that we can divide. First is the Litmus agent infra. Second is the Litmus backend execution infra. And third part is the application stack that is under the test, in which we are trying to inject our Kiosk. So a subscriber is basically what is mitigating between our Kiosk execution plane as well as Kiosk control plane, and it supplies different messages back and forth. So from there, basically, our Kiosk workflow is getting injected, and when it is running, we can see that how the Kiosk experiments and Kiosk engines will form in a short while we are running through the demo. So in order to show you how the Kiosk workflow works, let me just go directly to our Kiosk center. Before we actually begin executing our Kiosk workflows, let's have a short tour of our Kiosk center web UI. So as you can see, this is the dashboard where automatically one gets where one is able to visit once they are logged in. So over here, we can see that all of your past workflows, you'll be able to see all that Kiosk experiments that you have run in the past. Then we have something known as an agent over here, which will come to a short while. And finally, a project. So we have our users divided into projects over here. That is, user can be a part of multiple projects, while different users can be a part of a single Litmus environment where they can perform their different Kiosk experiments. So that this allows better collaboration between the teams. Therefore, we have this. Therefore, let's move on to the Litmus workflows. So here we'll be able to see our past workflows as well as schedule a new workflow that we'll be seeing just in a short while. After that, we're at the agent. So an agent is a small software, or we can say a small piece of application that we install in our host, and we use this for injecting our Kiosk. So there can be two types of agents that we can use. First is a self agent, and second one is an external agent. A self agent is used when we are trying to inject the Kiosk in the same cluster in which our Litmus is installed, or we can say at least our Litmus control plane is installed. So an external agent is therefore a external cluster. Like for example, I can target any other cluster in which there is a Kubernetes, like the bare minimum that is. So we can install the agent over there, and we can inject Kiosk into the resources of that cluster. So that's the concept of agent. So over here, we can also see that like we have one agent initialized over here, that is the self agent. And while we can have only one self agent, there can be multiple external agents. There is virtually no limit to how many agents that you can connect, and they can potentially run at the same time, and you can be used for injecting Kiosk. Moving on, we have our Kiosk Hub. So Kiosk Hub is actually a marketplace for open source Litmus Kiosk projects. These are the projects, these are the Kiosk experiments that we'll be using in our Kiosk workflows. So Kiosk experiments inject a particular kind of, they deliver a particular kind of Kiosk we can say they inject some kind of a failure, like particular failure. And we have right now over 50 experiments for different categories, such as we have experiments for bare metal, we have experiments for public cloud, we have experiment for Kubernetes. So that's a few experiments for you, such as Azure-based experiments, GCP-based experiments, AWS-based experiments, and of course, GCP experiments. So we'll be seeing in action that how these experiments perform in a very short while. Moving on, we have something known as an Observability Dashboard. So this is an inbuilt feature in Litmus that allows us to understand our systems under Kiosk in a better light. So we'll be seeing how observability works as well as soon as we schedule our Kiosk, and we'll be able to see a lot many different metrics over here. So that is a few that is a basic introduction to Litmus. By the way, I can show you a bit more details, such as, of course, this is the teaming panel where you can initialize your own personal details and other stuff. You can add team members to your project. You can manage user and their permissions. And finally, we have something interesting that is GitOps. So GitOps has a twofold application here in Litmus. First of all, it serves as a single source of truth for all your chaos workflows, if you desire them to be, such as we can configure Git to be your to work as a DB, and in that case, all our workflows get stored into our Git DB. That is, it can be any Git deployment, whether it be GitHub or any other private Git hosting, whether you like. It helps to serve as a single source of truth. And second is it helps with something known as event policies. So event policies basically help automate our chaos by defining some steady state conditions, some basically a set of conditions which when get triggered, so uh, that will help us trigger basically a chaos workflow when those similar set of conditions are matched. Moving on, we have our image registry where we can basically configure from where the chaos experiments are pulled from. So of course, right now we have our Docker Hub as installed over here as our registry server. So from there we are pulling the values, but of course one can use their own custom hubs as well as custom what we can say registry servers and Git. So that's a brief introduction to the Chaos Center web UI. Let's move on to an actual chaos experiment, which we'll be doing over here. So let's just schedule a workflow. So for this first demonstration, we'll be showing you how to perform chaos workflows or execute chaos workflows. So it's very easy to schedule a chaos workflow and execute it in Litmus using the Litmus Chaos Web UI, that is the Chaos Center. And to show that, we are actually going to use a predefined workflow of ours. So predefined workflow is basically something that we have created in advance so that you can explore Litmus at ease. So we'll be executing this potato head application. That is, we'll be trying to inject our chaos into this. So I'll be just selecting this potato head and we'll be going to next. And this is some description about it. That is, it's a potato head application. We are going to inject chaos on it and uninstall the application and revert the chaos. So if we go next, we can actually see the how our chaos workflow is composed of. So we can see over here we have a lot many steps. First, we have our install application step. Once we are done with the installing our application, that is the potato head application, we'll be installing all of our chaos experiments. So the experiments that we are performing as part of this workflow is only a pod delete experiment. The pod delete experiment, as the name suggests, will delete one of the instances of this application and inject by basically injecting chaos on it. So as soon as the pod is deleted, we wait for some time. That is known as the chaos duration. We wait for some duration. And then basically when the chaos duration is over, we then revert our chaos as well as we delete our application. Let us understand this chaos workflow in a bit more depth. So if we go to edit YAML, we'll be actually able to see our chaos workflow. Over here, you can see that our chaos workflow is consisting of a few different steps. First is our install application step. Next is our install chaos experiment step. Third step is the pod delete experiment, where we are actually performing our chaos, the pod delete experiment. And finally, we revert our chaos as well as delete our application in the same step. So if I just scroll down a bit, you can see that over here we have a lot much of the low level details of how this chaos experiment is going to be performed. So this is something known as a chaos engine. A chaos engine is basically, it defines a condition and basically in which we can force our application to be. That is, we are injecting the chaos using this chaos engine, you can say. So over here, we have some of our low-level details. That is for how much duration our chaos will take place. That is for 30 over here seconds. And we have our chaos interval of 10 seconds. So after that, we have also known as something as an HTTP probe, which I will explain just in a short while. So that is in a glimpse how our chaos experiments are structured inside our chaos workflow. Coming to how we have set up our experiment itself. So we can also mitigate the details of our experiment from this place. Like we can see that what is our target application. So of course over here we'll be targeting our application, that is the potato head, that will be also installed as part of this chaos workflow. And we are saying that okay, it is the kind of a deployment that we are targeting, and the app label of that deployment should be name is equal to potato main. And then we are saying that job cleanup policy is retained. So what we'll do is that all the low level details of the chaos experiment, that is the experiment logs, the chaos result, all of that will be retained so that we can see them. Next is we have something known as probes over here. So Litmus supports a lot many different probes. Probes are basically checks that we incorporate inside our chaos experiments, which run inside our chaos pod, like the chaos experiment pod, and they help validate a particular condition. So to give a better context of what is happening over here, we have an HTTP probe over here. An HTTP probe is, as it sounds like, it makes HTTP request to our potato head application, and it will try to validate whether that application is reachable or not. So if I see it in a bit more detail, we can see that, okay, the URL that the HTTP probe will be calling is this URL. And the criteria that we are setting is that the response that we should be getting as part of our HTTP request should be equal to 200, that is status okay. If the status is not okay, then of course this HTTP probe will fail, which will lead to the failure of our chaos workflow. So that is one of the probes that we are defined. By the way, there are more probes, such as we have something called a CMD probe, which will allow any command to be run as part of our probe check. Then we have something known as prom probe, that is for Prometheus. So if we go next, we can also again tune our chaos experiment for the total chaos duration. So we were seeing inside our chaos workflow as well that we had total chaos duration. This is the amount of time that for which our chaos experiment will run. Then the chaos interval, that is the duration between the subsequent experiments, you can say, or like if we have, let's say, more than one pods to delete, then in which interval the pods will get deleted. So after that, we have not many tunables, like these are some of the key tunables. So we can finish it over here. So that is in a nutshell how this chaos experiment is structured. If we go to next, we have our weights that we can assign to our chaos Litmus workflow. So for each experiment that we define in our chaos workflow, we can add a weight to it. So this weight is basically used for calculation of our resiliency score. What is a resiliency score? Resiliency score is a metric where we define how resilient is our application at the end of this chaos workflow execution. So for example, over here, it doesn't really matter like what score I give it, because it's only one experiment. But let's say if we have more than one experiments over here, we can actually define that how much weightage a single experiment carries, so that then we'll be able to average out our basically that how much resiliency score we are getting, and that is how much is the impact of a single experiment that we are calculating. So we can set it 10 over here. Let's go to next. And yes, so we can also execute these chaos experiments as part of a cron workflow, that is sorry, as part of a cron schedule. That is, we can schedule them either right now, or we can have a recurring schedule for them. That is, we can schedule them in every hour or every day or every week or every month. So for this demo, of course, I'll go ahead and schedule it right now. And we are in the final screen where we can just verify if everything is correct or not inside this YAML, or we can just directly go and apply this YAML. So let us go ahead and see how it goes. So over here, if we go inside our workflow execution, we'll be able to see this graph that will lead us through the steps of our different experiments. So these are the steps that are occurring as part of our chaos workflow. So this is the main workflow that is we are executing right now. It's the name that is potato head, then a serial. And then after that, we have our install application step. So in this step, we can see the different logs generated as part of this step, where it is actually where it is actually pulling the container for pod delete, and it is setting up those application pods and making sure all are in a running state, validating their steady state and stuff. So once this step is completed, we can go ahead to installation of our Kiosk steps, and from there we can validate that. After that, the pod delete experiment will take place. So it will take a while. Meanwhile, what we can do is that I like to talk a bit more about our Kiosk hub actually. So there is one thing that I missed about our Kiosk hub is that you can also connect your own hub to your own Kiosk center. So what will happen is that right now I have the default hub for our Litmus. So this is the hub that you can even access at hub.litmuskiosk.io that has all the different experiments that you want to have. But apart from this, you can have your own Kiosk charts as well, where you can have your own Kiosk experiments that you can make, and you can then connect a new hub using your Git branch and like Git repository. So that's how it works. Let us go back to our running workflow. So over here, you can also see a summary of all the workflows that have been executed in past. So this is the running workflow that had started a bit ago. So application installation is still taking place. Okay.
So just to add on other things, like currently the predefined workflow why we are running here is just for the new users. So typically this step might not be required by others because you are going to validate on the running applications. So here we are trying to set up an application, then trying to introduce a chaos on top of it. So that's the reason. So the first step will take a little more time. So this may not be required in a real scenario.
Right. So of course, after this demo, we have also scheduled a few more demos, like for showing you how we can inject chaos on an actual e-commerce application. So let's just see how this goes. Okay, so meanwhile, our demo is our application is getting installed, and after that, our chaos experiments are getting installed. We can, I guess, see a bit more about our pod delete experiment that we are trying to execute over here. So if we go to our documentation, this is our documentation for Litmus. This is the platform docs, or what we call the main documentation of Litmus, and these are our experiment documentations. So Litmus has an extensive documentation available so that it will help you regarding every aspect of how to get started with Litmus, and even the advanced guides that how we can use Litmus for chaos engineering. Moving on to our pod delete experiment. So if we go to pod delete, okay. It's not appearing over here. So as we can see over here, this is the structure of our pod delete experiment. We are over here, we can basically induce failure into specific or some random replicas of an application pod. So it tests the deployment sanity, basically the replica availability, as well as the interrupted service and recovery workflow of the application. So over here, we can actually see that how chaos engine for a pod delete experiment actually is. And we had also seen this chaos engine inside our chaos workflow that you saw a few moments ago. So we are basically defining over here the low level details of our application info. So for example, the application namespace, what is the application namespace that is to be targeted? Then the application label, that is over here, we are targeting our potato head application. And then the application kind, which is deployment over here as well. So after that, Kiosk service account. So I can, I guess, spend some time about what is Kiosk service account. So it basically grants a few set of permissions for the execution of our Kiosk experiments. That is the permissions that the Litmus can leverage from the Kubernetes in order to perform this experiment. After that, the name of the experiment, that is, of course, the pod delete experiment, and the different environment parameters. So that is how we actually defining the Kiosk engine. So probably by now we should be good with. Okay, it's still installing the application.
Is your Kubernetes cluster fine?
Hope so. I mean, of course, all our other resources are working, so not sure what is happening.
Can we can you check by AWS init and see?
Yeah, sure. Shall I just go to my KS console?
Yeah.
Sure.
Not from here, I think we'll not be able to get the case. You may have to use the.
Right.
Okay, so this is a good experiment to run on a demo. The chaos has been introduced by case, looks like.
Looks like it's working fine. Pretty sure.
Yeah,
okay, so there is some issue with our application installation. Okay, so this is what basically happened is that this workflow failed. And basically that is because the application couldn't get installed on the cluster because pretty sure what didn't get installed.
Looks like.
Yeah. So all right.
Rajesh, there is a hand raise. Can you take a look?
Yeah, sure. Akshay, probably can burden.
Yeah, meanwhile, I just like while you're figuring out, right, I just thought I'll ask a question. So like, how do you guardrail the experiments? Like, how do you define the blast radius for the experiment so that you don't get swallowed by the experiment itself? Is there a way that is there you're doing it, or is it something that you're looking to do?
Yeah, so probably I'll take this question. And meanwhile, Nilanjan, you can check out this part on the AWS side.
Sure.
Oh, sure. Okay. So actually, your question is like, what is the blast radius, right? So probably I'll just try to present my screen.
Sure. Shall I? Yeah, I have stopped sharing actually.
Is my screen visible?
Not yet. Yeah, it's coming.
Okay. So these are the marketplace, or like you can say that these are the experiments available publicly on Litmus. So if you see here on going through this experiments, right? So there are few experiments with infra things. So this means it can impact the entire set of node or a cluster. So the other applications are like other experiments, whichever you use, right? So will be limited the blast radius with respect to the things within the pod level, or it will not impact beyond a pod, or it's like, I will not say a pod, it cannot go beyond a deployment set of things. So in the pod delete, if you are using, so what it does is like it will go ahead and delete a pod. So let me take this example, right? Say here, if I take this experiment, right? So this is one of the experiment what you are trying to define here. So you can always set the things like app namespace. So if you are defining the app namespace as default, that means it will pick up in the namespace of default, and app label is like Nginx. It's like if your application is of Nginx and the deployment, it's like append is like deployment. It can be deployment daemon set or stateful set. That's what it will be defined. So based on that, these are the things it will take the control, and it will try to limit your experiment execution with respect to this one. So it will not go beyond this. So similarly, if you use a node level or the node experiment, etc., so it will go beyond the node. It's like, or if you are trying to have a in the node level also, you can set a entire node group things. So that means like entire node group on your cluster can be brought down. So it's like you can define your blast radius, or like based on your application, you can define the blast radius and take the control over there.
Thanks, Ajay.
Right, Charles, probably you can.
Yeah. Is there any option to limit the number of replicas this Litmus can delete?
Yes. So if you go here, so probably I'll go to experiment level docs. So let me get 1 second. I'll just take that experiment thing. I just wanted to show the experiment level, and then probably from here I can explain it better. So broadly, right, you have 3 major kinds of experiments. One is like generic, that means all Kubernetes related stuff. And there are few more at the cloud infrastructure level. So it's like this is like non-Kubernetes experiments, AWS, VMware, Azure, or GCP related experiments are there. So this in the Kubernetes experiment, if your question is on the, let's say, pod delete, right? So what happens here? So let me take a little more. There are tunables here. So here you can define so the total number of total chaos duration, then the chaos interval. So this is like if you are running for 30 seconds and say 10 seconds as your chaos interval, then it means like up to 3 times it can delete the pod, or like you can create the randomness so that way it will take the, it will say you put 30 and chaos interval of 10 and random is S. That means it can delete 3 times, or it can delete 2 times, or it may delete only once. Then you can define like whether it is to be forcefully you want to delete, or like target pods. You can say how much you want to, what all target pods you want to define, delete in the app labels also, whatever you have put. Additionally, you can put the pod affected percentage. So if you put the pod affected percentage, so by default it will delete only 1 pod. So if you put like 100%, then it's like if you have 10 replicas, all 10 can go down at the same time. Or like you can say 50% means like 5 pods, up to 5 pods it can get deleted. So these are the tunable.
Got it. Thank you.
So what we try to build with Litmus is like we try to build a platform such a way that you can customize your own experiment, and you can have like a probes and other stuffs. You can use it, and you can build your own experiment as per your need. So this pod delete experiment can be just like you go ahead and delete the pod. So what by default it's what this does is like it deletes a pod, and it checks whether the pod came up or not by the native Kubernetes API. So just the pod showing running state does not mean that pod is really up. So there should be like liveness check and readiness check, so many other Kubernetes infrastructures you have, or like if you can have your own definition, like whether the pod has come up or not. Using some probes, you can always define, or like you can run some traffic and see that whether the system is like up and running, that kind of things, like whether the application itself is running or like the application is able to read and write. Those checks you can do while constructing the work.
Just one more hand raise is there. Basil.
Hey, Basil.
Yeah, two questions. One is there is a GitOps option. What that means is any change that you make in the workflow will automatically get synchronized in the GitHub. It gets pushed into Git. And that also means that we can manually make the changes in the workflow in the YAML file, and we can push it, then it will get synchronized to the UI. Is that what the purpose is?
There was your voice was a bit muffled. Let me repeat the question. I understood right. So your question was like on the GitOps part and how GitOps can help. Is it the right question? Did I understand correctly?
My question was, so GitOps allows you to work both in the UI and also directly on the Git repository, and it will be in sync.
Yeah,
that's right.
Yes, you are right. So let me put the GitOps the way we have defined. So GitOps will help you to work your experiment in a GitOps or a Git enabled manner. So what we do is like we have two types of GitOps or like Git operations we can do. The one is like front end GitOps, where you configure like Git as a repository in Chaos Center. So once you Nilanjan, if you can paste your Chaos Center URL, I can just log in.
Shall I just share my screen? Like,
Yeah,
it will be easier. Yeah.
I'll stop sharing. I'll try to answer. Okay, so you can go ahead.
Yeah.
The settings. So there are two settings, Basil. So one is like Git as a repo. So by default, whatever configurations we do will be stored on our local DB. So in our case, we use MongoDB. So then what happens is like when you construct a workflow, everything is a YAML. So that gets stored in MongoDB, and then it gets deployed into the respective Chaos agent. Once you configure Git as a repository, right? What it does is like any configuration you do will be first pushed into Git, and the Git becomes your source of truth. So that means like Git will you have your all your workflow in Git, and it will be like version control, and you can keep track of like how the changes has happened. That is one way of Git. The next one is like you can modify in the Git itself. That is the second part of your question. Like you can modify in Git, and that same change will be reflected back into Chaos Center, and we get executed. Say, for example, you are going to run it as a cron job, and you want to update your schedule, or like you update your configurations by like changing some workflow. Those things will be applied from Git, and the same thing will be read by Chaos Center, and then the operations will be performed onto the respective Chaos agent. And third part will be like event trigger chaos also we have. So that means like you change in something in your Git repo, that can be you can have your own CD mechanisms like Flux or Argo CDs or any other CD mechanism tools if you are using. So for example, like you have updated your configurations, say Nginx version, you updated from version 1 to version 2, you upgraded. So automatically you can configure to have an event saying that on an upgraded event, you can run set of Chaos workflows. So that way on upgrade, you can automatically this workflows will get triggered, and you can see whether all the chaos results passed. Then you can move to the production, or like if you have like a blue-green deployment kind of things, you can set that kind of environment there.
Awesome. And is there any other way to trigger, like if it's an external URL, is there any webhook kind of triggering that I want to call a post, make a call to a post request a URL and job get triggered, anything like that?
So your question is like, do you have webhook to initiate workflow, right?
Workflow, yeah.
Okay. So you can. So what we have done is like the Chaos Center itself is like built on completely on the GraphQL APIs. So you can call the GraphQL APIs directly, and you will be able to initiate any workflows directly through the workflow items. You can click on the API doc.
All right, API docs.
So we have two main set of APIs. Like one is like authentication related APIs, and the workflow is on the GraphQL side of APIs. So you can call the entire set of experiment or the workflow directly through this set of APIs. And also currently this is the available things, and we are now trying to build up a one more utility called Litmus CTL. Currently it supports only the agent connect part. So Litmus CTL is built similar to kubectl way, where you can execute the commands of this.
Great. Thanks.
Okay, so are we good to continue with the demo?
Yeah, go ahead.
Okay, so I'm suspecting that what has happened is too many pods are actually scheduled on our cluster, so we are hitting the pod limit actually. So that's my suspicion, that why it got disabled, like why we are not able to do it. But on the positive part, I've been able to work out the CLI part. So first of all, I'd like to show you guys that how the Litmus pods are coming up. So that is what all gets installed as part of the Litmus. So if I do this, we'll be able to see all the resources that are getting installed as part of Litmus. Okay, so yeah, here we are. So as we can see over here, that is as part of our Litmus, basically we are getting these many things are getting installed. First of all, we are installing our front end. This consists of the web UI that you are seeing right now, using which I'm scheduling my workflows. Second is the Litmus portal server, or this provides us the APIs that Ajesh was just mentioning. So this is the GraphQL server, basically, that is serving to all the API requests made by the front end or directly accessed using the Litmus API. Second one, like the third one, is the MongoDB. So the MongoDB is used by both the authentication server as well as the GraphQL server to store a bunch of user information as well as the authentication related information, past workflow information, then information related to chaos result, that is what is the result of a chaos workflow execution, stuff like that. Apart from that, we have something known as a subscriber. So subscriber is what we are using to communicate with Litmus agent. So this is the front-facing component that communicates with our GraphQL server and responds to whatever chaos workflow execution queries that we posted. So this is basically a middle component between our execution plane as well as the chaos control plane. Lastly, we have our workflow controller. So the workflow controller is okay, fine, it is running right now. Yeah, so we have also something known as chaos operator. Yeah, here it is. So chaos operator is something that is the main chaos component that is used for it is actually a Kubernetes controller which actually brings our chaos resources to a desired state. For example, it monitors for our chaos engine, and once it finds our chaos engine, it responds to its any CRUD operation. That is whether it is create, read, or update or delete. The chaos operator responds to it. It reads the state of our chaos engine and then makes modification to our current existing state of our system so that the chaos gets injected. So chaos operator then again creates a few more different resources such as chaos runner, then chaos jobs, a few other things. So apart from this, we also have our chaos exporter. So chaos exporter is responsible for exporting our different chaos metrics to other observability tools such as Prometheus and eventually Grafana. So we'll be seeing our chaos exporter in action as well in just a short while. So that is for the pods that we have, and these are basically the deployments that assist to pods as well. So next we have, yeah.
Sorry, I can see the potato head. This is the install applications you try to do. So this for other viewers also. It's like you can see that few of the things are in pending state. That means like your Kubernetes cluster is not able to add these items there. So if you describe those things, probably it will say that your Kubernetes cluster is not able to do. So in case if you are trying to showcase the other things, probably you may have to delete this potato head application and then go ahead.
Right, I'll do that in just a second. So sure, before I do that, let's just finish the different components that we have over here. So next, actually we have our services that are responsible for it. So Litmus portal service is what enables us to expose a node port that will lead us to access our Chaos Center web UI. So that is the port, the node port on which we are accessing our Litmus frontend. And similarly, we also have our services for server and a few other components such as Kiosk exporter. Similarly, we have our replica sets as well as stateful sets for our database over here and a few other components that are basically sustaining our other components. So let me just quickly actually delete all our components. So meanwhile, if there are any other questions, maybe Ajesh would like to take them. So I'll be done in just a second, I guess.
You can just delete the potato head app. That should be good enough. And probably, okay. In the meanwhile, if Sibin has raised a hand. Sibin, go ahead.
Yeah, just so Niranjan was showing the user authentication in that port settings. I mean, in the settings of Chaos Center, right? So I'm asking, like, what is Chaos Center supports an SSO kind of authentication to the portal to add multiple members, or is it like any kind of SSO we can integrate, or is it like platform specific, like AWS or IAM and GCP IAM based authentication or something like that?
Okay, so we currently have only the local authentication, and there is a code already submitted from open source contributor where you can integrate with DEX. So DEX is another identity provider where it can integrate with other providers like say Gmail, GitHub, or any other LDAP set of things. So you can do the code. By native, it does not support. So it gives only the local authentication. The teaming functionality, what it helps here is like, if you, by default, right? So you can, in your organization, you can have one single chaos center, and you don't have to have multiple. If you have team members who wants to run chaos and all, right? You don't have to install chaos center in multiple places. You can use Chaos Center as a single piece, like a control plane, and others can connect their agents to that and try to inject chaos into their agents. So what we provide is like the teaming functionality is like you can create multiple users, have them access, and each users can invite other team members into their project, and they can share their resources. So that way you can collaborate and do the chaos engineering in case if you want to do.
Okay, thank you.
All right, I guess we are good to go with our second demo. Or Ajesh, what do you think? Shall we go with our first demo again?
You can go ahead with the second one, because like there you don't have to install the application again. Its application is running and it should go through. Looks like Nilanjan has gone with a very minimal Kubernetes cluster, where it has been limited with a set of pods. Like there are like it's a 1 or 2 node cluster where he has only few plus pods can run by default, and he has select. I was just checking the resources also. It's like 4 GB RAM machines.
Right, that is what has happened. Some actual chaos in a Litmus chaos demo. All right, I guess we should be good to go now. So because I've deleted most of my resources, so right now I guess we are good to go with our second demo. So okay, so this will be a much more elaborate demo. Well, I'll show you that how we can inject chaos into an actual application. So for this purpose, we have this application before us. It's a demo e-commerce application known as a sock shop. So you can imagine like this is an e-commerce application for different socks that people can buy. So this is a typical e-commerce application. We have our own catalog where we can see our different socks and we can browse through them. We can proceed to buy them. We can add them to cart, and a few other options are there. So what we'll do is that we'll simulate an actual chaos scenario where we'll try to inject chaos into this catalog. So before we inject actual chaos, what we are trying to see over here is that this application, of course, is consisting of a different microservices. Each of these sections, such as our catalog or our cart, is a separate microservice. So we are trying to check the resiliency of our catalog pod over here. So that's what we are going to do. We'll be injecting a pod delete chaos into our catalog pod over here. And this time you will be able to see that how the pod delete experiment affects our application. So before we go into the demo, I'd like to show you the application deployment from my cluster. So I'll say, right. So over here, we'll be able to see the different resources that we basically have inside my sock shop application. So over here, you can see all these pods are basically sustaining my sock shop application. We have different components such as you can see inside deployment, we have carts, we have catalogs, we have front end, we have orders, we have payments, a lot of stuff. So out of all these, we are actually trying to target these catalog. So this catalog pod is what you're seeing over here right now. This is the catalog pod that is enabling us to check out these products. So in an actual environment, you can imagine that if a application microservice has this catalog, let's say you are browsing in Amazon and you're trying to buy some stuff, you're browsing them, and if it goes down, that certainly won't be very good. So that is what we are trying to see over here, that whether this application will be able to sustain the effect of a pod delete of this catalog or not. So over here, I will also like to point out to you is that it has only one pod over here. Like we are saying that there is 1 out of 1 pod available, and we have only one replica of it. Therefore, if this replica has to go down, the catalog will be totally unavailable. And that is what is going to actually happen in a while now. That is our and this catalog will be rendered unusable. So to do that, we'll again go to our chaos center and then schedule a new workflow. Over here, we can schedule a new workflow. We can go to self agent and then next. So over here, actually, I've already defined our workflow to save us some precious time, but no worries. I'll be actually showing you that what is inside my workflow. So let me just add my workflow over here. Oh yes, by the way, you can always save your workflows, your Litmus workflows as a YAML file. And over here, you can add your predefined workflows, or even you can save them in your own database and then add them from here using templates. That is, you can templatize your own workflows. So anyway, we have added our own sockshop YAML file. That is our workflow that we are using, which will be injecting chaos into our application. So let me just write over here sockshop workflow. And next we can see that what is this is about actually. So over here we can see that there are only two steps over here. First is install chaos experiment, and second is the actual pod delete experiment. So like before, over here we don't have an install application step because, well, we already have our application, that is our sockshop application. So right now the only steps that we need to perform is that to install our chaos experiments, and out of those experiments we'll be executing our pod delete experiment. So let me just walk you through the different parts of this application. So over here you can see that the experiment name is like catalog pod delete. You can name this anything, that is, this is the step. You can name this catalog pod delete or whatever. I'm named this catalog pod delete. Then if we go next, we can see that over here what are the targeted parts that like we are trying to target. So the application namespace is sockshop. So as I've shown you in my console as well, all of these resources lie in our sockshop namespace. So I'm referring to it here as sockshop. Then we are defining our application kind, which is deployment. So we are basically trying to target this deployment, which has only one replica catalog, right? So we are saying deployment over here, and then we are providing the app label, that is name is equal to catalog. So if I have to show you the labels, so if I say kubectl get deployments, so over here we'll be able to see the deployments of the we'll be able to see the labels of the deployments that are part of the sockshop namesop. So over here you can see catalog has this label attached to it, that is name is equal to catalog. So we are targeting it using name is equal to catalog. Therefore, again we are posting our job cleanup policy as retain because it will allow us to see the effects of the chaos. So if we go next, again we have defined a probe over here. So this is again a HTTP probe, and in this case we'll be checking whether our catalog is accessible or not during the chaos duration. So if I just see these details, you will see that this is verifying a URL, which is this. So if I just go to this URL, you'll be able to see that it is supplying all of our information that is getting displayed into our application in this page. So this is the API that is basically responsible for providing all the data that is available in this page. So we are targeting this, we are checking for this API actually. Anyways, so this is the API, and again our method of verification is we are checking whether the response status code is 200 or not. If it is not 200, we can be sure that something is not right. Again, we have defined a response timer, that is for how long our check should continue before it flags the check. So of course we can define more probes, but for now HTTP probe will do. We can go to next, and again we have a total chaos duration. Let's increase the duration for a while, like we can say it for 60 seconds over here, and we are done. So that is how our experiment is scheduled right now, and let us go to next. Again, there is only one experiment, so I'll keep the experiment weight as 10. Let's go to next and schedule it for now, and we can finish over here. So again, our application is running. Our chaos workflow is running. And over here, we can see that the install chaos experiment step is running. So it is responsible for installing all the chaos experiments that are part of the workflow that we are trying to inject. That is the pod delete experiment in this case. So right now, as you can see that these pods are basically, these logs that we get basically are on demand. That is, once they are all generated, we'll fetch them at once. And that is by virtue of the subscriber that is present inside our chaos execution plane. And over here, you can see that pod delete experiment is actually installed, and we are proceeding towards the actual pod delete experiment. So right now over here, as you can see, the experiment logs are yet to generate. And if we go to our actual application over here, if I try to refresh this page, okay, it's still available, but in a while it will be rendered disabled actually. So let's just keep checking. Okay, so as you can see right now, the application, the workflow, that is the pod delete experiment, has successfully targeted that API. And since it has only one replica, our application is now rendered, cannot be rendered anymore. The catalog information is all gone. And this is the type of chaos that can actually happen. For example, if there is something, some condition that is leading to the instability of that pod, of an experiment pod, or like a deployment pod. So in that case, this pod can basically be not present, or it can get deleted. Anything can happen. So in this case, we can be certain that our chaos experiment has actually failed on the virtue of the fact that our chaos probe will actually fail. That is our HTTP probe. So we'll be actually able to see all that detail in a while. But for as long as the chaos duration stays, that is for 60 seconds, we won't be able to see this catalog because the pod has been deleted basically. I can also confirm this from my console. So if I just try to get my deployments again, you will be able to see that the catalog now has only 0 out of 1 pods available. So therefore, chaos pod delete experiment has basically deleted this pod. So we would now have to wait for 60 seconds for this to come up. So Litmus also provides us observability from the Chaos Center itself. We can monitor our experiments from here. And we can also see this in the Grafana dashboard. So Litmus also helps integrate different third-party observability tools, including Grafana. So if we come over here, we can actually see, if I select all of them, that currently our chaos experiment is running. And over here, since we have targeted our catalog, I will try to divert your attention to here. So as you can see, this the part that has been annotated in orange refers to our chaos duration. The start of the duration, you can validate it by the time duration, like when we had started, and up till the duration it will continue. As you can see, other services are working just as expected. You can see these are some other services such as shipping, payment, user QPS. By the way, QPS stands for queries per second. But you can see particularly the catalog QPS has gone down, and in fact it is completely unavailable at this point because there is in fact no pods that can serve to this metric request. So therefore the Grafana is unable to fetch any metrics related to this. Not basically Grafana, but the Chaos exporter, it is not able to fetch any metrics. So therefore it is completely rendered blank over here. So as soon as the chaos duration passes, we will be again able to see like the graph goes on to its normal, but for the time being, it's not visible. We'll be also able to see the different details of our chaos. Okay, so our chaos is actually completed right now. So if we go over here, okay, it's still showing completing, but we can confirm from here that the chaos is completed, and we can see that there is a purple annotation right now just after the orange annotation. So that denotes that our experiment has completed. And right now we can see that the experiment's verdict is awaited. That is, it is still being calculated that what is the verdict of the experiment. And then we have our other information such as the result namespace where the chaos result is getting generated. And we can again see that right now again the QPS is working. That is, you can see there is the QPS metric is again getting generated and the load is coming. So right now, if we again go to our application and reload, here we can see our application is back to life. And if we go to our, yes, so over here we can see that our pod delete experiment has actually failed. So if we go to our chaos result, we can see the additional details about why exactly it got failed. So if we just go down over here, we can see that the experiment verdict is fail. We can see that probe success percentage is set to be 0. Now this probe success percentage actually refers to our HTTP probe, which was checking for our catalog URL continuously. So you can see I had defined the probe name as check catalog access URL, and it is a HTTP probe. And you can see that it says better luck next time because of course it failed. And we can over here see that there is failed run equal to 1. So of course this all the information is summarized by Kiosk result, which accumulates all the details of our experiment run made over time. That is how many experiment runs are passed, how many failed, and so on. So that is in a nutshell how this Kiosk result is getting generated. Before we move on to our next demo, I will just like to show you the internal built-in observability capabilities of Litmus as well. So I have set up a data source over here, that is Prometheus, from which we can create our own interleaved dashboards for the different applications that we are subjugating our Kiosk into. So of course we have only Sock Shop over here, but we can have multiple dashboard. And if we go inside Sock Shop, we'll be able to see a host of different metrics as part of this this dashboard. So as you can see over here, the catalog QPS, the same metric that we have been observing from Grafana, it is also confirming that during the annotated duration between the Kiosk duration, the QPS or the queries per second for catalog went drastically low because of course there was no pod to sustain those requests. And as soon as the Kiosk duration over here is over, you can see that the queries are in fact back to normal, like everything is on normal right now. So that is how this pod delete experiment works, this ultimate application of pod delete experiment that we can show. So if anyone has any questions, please. Okay, I guess no questions. All right, fine. So
Nilanjan, one question.
yeah, sure.
Okay, so in between the pod got failed, right? I mean, the experiment got failed in between, right?
Right.
So and the failure will not affect the reconciliation any times, right? Or for all the experiments. Okay.
Right. So we have something also known as a revert chaos step. In this experiment, I had actually turned it off because I wanted to show you that how the results are getting generated. So as part of the revert chaos, we are ensuring that all the steps that we have actually performed as part of our chaos injections are getting reverted. That is, in this case, like for example, we are deleting a pod. So of course, we are ensuring that the pod again comes up. And in the next case, for example, we'll be again seeing a AWS experiment over there. I'll again explain you what the revert step is doing. So this revert steps takes care of the fact that every change that we have made to our cluster as part of our chaos injection gets reverted. And this revert step also gets injected as part of our chaos abort operation. So for example, we are seeing that our pod delete experiment is taking place, but something very unexpected happens and we need to abort our chaos workflow or experiment right away. So what would happen is that we'll of course generate a panic signal, and of course the workflow abortion will take place. But we also take care that before aborting from the workflow, or basically before we completely exit out of workflow execution, our workflows get reverted completely. That is, all the effects that we are creating as part of our chaos workflow duly gets reverted. So yeah, that's basically what is happening. And I can actually show you, like if we again go to kubectl get deployments, of course we are able to access the our catalog, so it's back online. So that is how it's happening. And yeah, so I hope I answered your question.
Yes.
All right. So just something before we move on to our next demonstration. So over here, we can see our experiment logs, which are also part of our experiment observability. So you can trace out the different steps as we are conducting our experiment. So over here, we can see that like how the experiment environment variables are getting fetched. So these are the different chaos duration or chaos interval that we are earlier setting. Then we have our AOT test. So basically AOT test is something, by the way, we can also see RAM time and a few other details over here. I forgot to mention about ramp time. So ramp time is basically some amount of initial delay that we are adding as part of our chaos experiment that would cause the chaos experiment to initiate after some duration of time. So that time duration is basically the ramp time. So we can set it basically for some purposes. Then we have our Aot checks. So Aot checks are performed as part of our steady state validation so that we can verify that all the application resources that we are trying to inject the chaos upon are in a steady state. So once we are basically verifying that, we are then running through of our pod delete application, and it says that we are trying to target our catalog pod delete. Basically, this is the pod where our experiment is running. And then we are trying to delete the pods. That is, we are checking a few different things. That is, check catalog access URL. So this is actually the HTTP probe check that we are doing over here. And then we are trying to see, we are actually saying that the actual value should be 200 for the HTTP response status, but it of course failed, so we couldn't verify that, and that can be seen over here. Like it says, check catalog access URL probe has been failed. So this was the main reason that our experiment failed. All right, so this is all about our pod delete experiment. Now for the final demonstration of Litmus Chaos, we'll do something known as a infra chaos experiment. So for this, as part of our experiment, we'll be using our EC2, we'll be inducing chaos into our EC2 instances, and the name of the experiment is actually EC2 instance terminate instance. So as part of this experiment, what we can do is that we can basically delete, we can basically stop or terminate any running EC2 instance and then make them back online. So this was, of course, create some infrastructure chaos. For example, if you have any application deployed on your instance, on your EC2 instance, it can get stopped, or a host of different type of chaos can take place. So let us see how can we perform infra chaos from Litmus. By the way, EC2 is not the only, AWS is not the only platform for infra chaos that we support. We support VMware as well, we support GCP as well, we support Azure as well. We have different experiments such as EC2 instance delete, we have VM disk delete, a few different experiments. So without any further ado, let us try to delete this particular EC2 instance and see how does that affect us. So what we'll do is that we'll then again schedule a workflow. So we'll go schedule a workflow, go to self agent, and then we can use our Chaos Hub. So of course I had introduced you the Chaos Hub before. Over here we have all our predefined experiments, and EC2 instance delete experiment is also a predefined experiment, so we can directly use it from Kiosk Hub. So we should go next, and I can say over here EC2 terminate. So once we are ready, we can go to next, and over here we'll add a new experiment. So this is generally how you will actually define a chaos experiment. So I'll add a new experiment over here, and we can then search for AWS. So I can see that this is the cube AWS EC2 terminate by ID. We'll be terminating the EC2 instance by its ID. So we'll click on done. So we'll see that our experiment has been added over here. Let us add a few more details, or basically customize our experiment. To do that, I'll go to edit YAML. And over here, we'll be basically specifying our EC2 instance for which we are trying to inject our chaos. So we'll be actually copying this instance ID for which we are trying to inject chaos in this test instance. Just copy it, and I'll paste this inside our EC2 instance ID. Again, we are also supposed to give the region in which our EC2 instance lies. So it is actually in AP Southeast 1 region. So I'll copy that and paste that as well. Okay, now for one final step, that is basically how do we authenticate Litmus with the AWS platform, because we cannot directly we cannot directly go and delete the instance, of course, because that would lead to unauthorized access. So in order to do that, we are basically supplying our credentials using a secret. So for those of you who know what Kubernetes secrets are, those are used, this is basically used for supplying the secrets or any type of credentials or secret information to your Kubernetes cluster. So this is the Kiosk engine workflow that you can see over here. It's the Kiosk experiment, excuse me. So inside this, we are actually supplying one of our secret known as cloud secret, and the mount path is /temp. So this cloud secret shall contain all of our credentials that is required for our AWS. So what are the things that are actually required for this? So in order to see that, let me just go to the our documentation. So we can say Kiosk github.io. Okay. So over here, you can see the structure of our Kubernetes secret that we need to provide. So basically, we just need two things. First is the AWS access key ID for your account. And second is your AWS secret access key. It will be a cloud secret or like whatever name you give. This doesn't really matter, but it should be an opaque secret that we are providing. So once you have basically created this secret, the container in which the experiment is running, basically it creates a cloud config.yaml file that gets mounted into the temp directory. As you can see, we are specifying the mount path as temp. From there, we can basically fetch all that information and authenticate our request to basically cause chaos or basically turn off the instances in this case. So I've actually already created this secret. Let me just show you. So this has to be basically created in our Litmus namespace. So if I say kubectl get secrets -litmus, you will be able to see that the cloud secret is created over here. All right. So we are actually all set to perform this experiment. So all the details have been fed. So I'll just do a save changes, and guess we can go to next, or we can actually see like without cleaning up the Kiosk resources, the steps of the experiment. Let's go next. We have our resiliency score set up. Schedule now and okay, finish. Okay, so the workflow has been scheduled. We can monitor our workflow over here. So the Kiosk experiments are right now being installed. So we'll be actually be able to see the effect of this Kiosk on this dashboard over here in our EC2 dashboard. So right now the experiment is just installing. Let's wait for a while. Okay, so our experiment has started actually. So right now it's just about to begin. All right, so it has started executing, and if we go over here and if we refresh, it's still running, but in a short while it won't be running. Just getting done with the pre-Kiosk checks. So as you can see right now, the state has instance state has actually now become stopping. So this is because the this experiment, as I explained, it uses the Kubernetes SDK, like the Golang SDK for this AWS to inject chaos. And as part of the chaos injection, it basically first of all verifies whether the instance is running or not. Since the initial state of our instance is running, it then basically stops the instance for our specified time duration. So I guess I've set some specified total chaos duration. So for that specified duration, our instance will basically get stopped. So right now, as you can see, it has completely got stopped. So, but as part of this experiment, we'll also basically revert all of our changes. That is, these stopped instances will be again running as well. So we'll just have to wait for the chaos duration to pass, after which we'll be able to see that our instances are again running. Okay.
Yeah. Just move to pending state.
Right. Okay, so again, right now our chaos is running actually. Right now the status checks are initializing. That is, our chaos is actually over, but it is our experiment is basically getting done with the post chaos checks and all. That is, it is verifying whether our instance is actually running or not. So this is also a basically steady check validation. That is, during the post chaos validation, if we found that for some reason if the instance failed to start, then again the experiment will actually fail. So those are the checks that are actually running right now. So once this is done, basically the experiment will get over, and this experiment should actually pass since, well, our instance successfully started again. Okay.
I think we are almost time. Any questions? Final few questions, we can take it up.
Right. All right. So the instance.
Yeah, Sujit has raised a hand. Please go ahead.
Yeah.
Sure.
Yeah. Thank you, Nilanjan, for your great explanation. You just mentioned about a term called infra chaos, right? So how is this infra chaos different from the other kind of things, other kind of experiments?
All right.
What
So
all would come under infra chaos?
Right. So let me just refer to the slide that I had shown you before. That is the presentation slide. I would like to turn your focus to the pyramid that I had shown you, the resilience pyramid. So just give me a second. Basically, I had explained that, of course, our resiliency of our application is not something limited to our application. It, in fact, depends upon a lot of different things, such as there is different applications that our application depend on, such as there is MongoDB database, let's say, or of our Postgres SQL database. Then again, there are cloud native services such as Cloud Core DNS or Prometheus. Then comes Kubernetes services, and finally the infrastructure. So the point is that when we say infrastructure failure, or the infrastructure experiments, we are trying to target at the broadest possible level, and we are trying to render chaos into our infrastructure. So this infrastructure can be your bare metal. It can be your self-hosted Kubernetes cluster, like using VMware or something, or it can be any public cloud. Like, for example, we are using AWS over here, but we can also use GCP, Azure, you name it. So that is what I was actually referring to infrastructure over here. These are the infrastructure level of experiments. So actually, we are categorizing our chaos experiment into 3 categories. First is the infrastructure level experiment, then we have pod level experiments as well, and then we have our public cloud level experiments as well. So these are a few categories you can see, like the distinction.
Yeah, thank you.
Sure. All right, we have another question, I guess. Okay, no questions. So yeah, I mean, just before signing off, these are basically the experiment logs. As you can see, we are going to the experiment as it is starting, and then application under test, we are doing the pre-chaos checks. And once the pre-chaos checks are over, we are basically stopping the instance, and we can see that the instance is stopping. It goes on to stop, and then we are waiting for our chaos duration. So once the chaos duration is over, then we are basically again starting it. So it goes from pending to running. Then we perform our post chaos check, and once everything is found to be okay, we just proceed to end the experiment. So yeah, this was in a nutshell how Litmus Kiosk works, and we are very positive that with the increasing number of cloud native increasing number of organizations that are now progressively moving to a cloud native infrastructure with Kubernetes and other cloud native services. Chaos engineering will play a very vital role in ensuring that customers, for the organizations who desire for their customers to have uninterrupted and very resilient services, chaos engineering will definitely pave a path for it. So I really hope you had a great session and got to learn something new from this session. Thank you, everyone.
Thank you, Nilanjan and Ajesh. Indeed, it was a great session. Like most of us are new to this. Like, yeah, some of us work in Kubernetes, but chaos engineering itself is like one of the most sought after practices in DevOps. So it was like a nice talk. Thank you very much once again. Sibin, are you there?
Yes, I am.
Yes, please.
Okay, so today was a special day for DevOps Malayalam community, and we had a nice demo from Chaos Native. So I would like to thank the speakers and all the guys. So first of all, Mr. Mumshat Manambat, within a short notice, he was able to join us and performed our website inauguration. So I am really thanking him in the name of myself and in the name of our community and all the speakers and moderators and all all the listeners of our community. Then for Ajesh and Nilanjan, thank you very much for accepting our invitation to present the topic, this awesome topic, Chaos Native, and to present the tool Litmus in a very nice manner, even though there are some flaws where we experience. That's usual in case of some demos, so, but still you showed a pretty good part of the experience that is already in Litmus, and we enjoyed and we learned somewhat, and hope we will be able to practice the tools and its methods in our projects also. And I came to this Litmus and the Ajesh team during the first lockdown time during the last February. So I was watching some of the videos from meetups and some of the community. So I attended 2 or 3 sessions as part of Litmus monthly meeting. So, and I presented the tool within my previous company, and from then onwards, I was following your release notes and your meetup short notes and all. That's why I reached out to you guys to present the tool and its scope within this community and within our using our native language also. So that's the way, I think that's the way we need to spread the knowledge and spread the technology to all members belongs to our community. So anyway, thank you guys, thank you very much. And then I'm thanking all the listeners who are here, who are supporting us, and who is always sending us suggestions regarding the topics, then whatever knowledge they need to get and whatever tools they want to explore. So we are getting pretty good response in all the social media platforms. So I'm thanking you all. And then our speakers, they are the backbone of our community, because whenever we are approaching with any kind of topics, many of us or many of the members from the speakers are there, like Manojat, and then Basil, then Rajesh sir. So everyone are there, then GeoChat, and so everyone is there to support us to host a session on any kind of topic, for whether that is for a beginner level or that is for an advanced level or like an expert level topic. So we have people to reach out there. And then the last but not least, the moderators team, including me, Jijo, then the Sharath, which Jijo already mentioned, and then Yebin, then Alexi, and then Pranoy is there, then Jasim and Nasif. All those guys are there, even though few of them are students. They are able to manage the time, and they are able to support us only because of the knowledge they are getting. Other than that of the syllabus they are studying, they are getting a pretty good exposure to the industry standards and technologies. So I'm appreciating everyone, and I'm very much thankful for everyone to be with us, and I hope that everyone will keep support us. So Ebin will share a form to provide your feedback in this chat and also in our social media platforms. So please share your feedback so that it will help us to improve, and it will bring more topics and more speakers into the group. And also I'm supporting and also I'm thanking Nida for working hard to make the website live today. And we were actually fighting to sort most of the issues where we were facing, and the website and Nida were handling it pretty good, and she was able to deliver it on time without any issues. So I hope everything went well with everyone, and thank you very much. Yujo and Debin, if there is anything to add, please.
Yeah, I think you have pretty much covered everything. So our next session will be in Clubhouse on Wednesday, but the topic is not decided. So we'll be informing you via our social media platforms. Eben, do you have anything to add? I think Eben is not here. So, okay. Thank you all for joining us for this inaugural ceremony and demonstration. Oh, yeah, yes, Eben. Oh, okay. In that case, I think we can wind up.
Yeah, we can wind up.
Okay.